Welcome back to video number 11. So our goal for today, given any function, you will be able to calculate the rate of change between 2 points. Okay, so we're going to start today by looking at some old material. So let's take a look at just lines. So here we have 2 lines. All right, so what I'd like you to do first is take a look at the first line. I'm going to outline it in blue. Okay, so let's go ahead and explain what is the rate of change of this blue line. Well, remember, in the past, rate of change, so rate of change is just a fancy word for what? It's a fancy word for slope. Okay, so if we were to take a look here, what is the rate of change of this blue line? Well, taking a look at it from left to right, is it going up or down? Well, it's going down, so that means it's going to be a negative rate of change. Okay, and can we actually calculate its rate of change? Well, let's take a look. We're going down 1 over 3, down 1 over 3, down 1 over 3. So is its rate of change constant? Is it going the same? Is it changing the same amount every single point? Well, yes. So that means our rate of change, so rate of change is going to be negative 1 over 3. Okay, so now let's take a look at our second line. I'm going to outline this in orange. Now, if I take a look at this line here, what is the rate of change here? Well, first off, let's just make the decision. Is it negative or positive here? Our line is going up, so our rate of change is going to be positive. So as your x increases, your y is going to increase. Okay, and let's take a look. Well, what is the rate of change here? So the rate of change is going to be, well, let's go from point to point. We're going to go up 2 over 1, up 2 over 1, up 2 over 1. So our rate of change is 2 over 1. And is the rate of change constant the entire time? Well, yes, you're changing the same amount no matter where you are on your line. You're always going up 2 and over 1. Okay, so let's take a look now at these 2 lines. We have a negative, we have a positive. Which line is changing more quickly? Well, this one's changing more quickly because it's steeper. So if it's steeper, it's changing very rapidly. If it's just a gradual, that means its rate of change is very slow, hence why its rate of change. Here it's a fraction, here 2 over 1, it's a full integer. All right, so rate of change is very easy when we look at lines, but now if I were to give you a parabola, what is the rate of change of a parabola? Is it the same the entire time? Well, no. If I look at the rate of change over here, if I were to trace my parabola, am I going up or am I going down? We're going down. So what's my rate of change? It is negative. Okay, what happens on this side? What's my pen doing? It's going up. So over here, my rate of change is positive. So when you start looking at functions like a parabola, we can no longer use the word slope because the rate of change is not the same. It's different depending on where you are and what points you're between. Because if I look at my rate of change from here to here, this line is very steep. So it has a big rate of change and it's going down, so it's going to be negative. Now, if I go over here and I go from these 2 points, again, it's very steep. My rate of change is big, but this time it is going to be a rate of change is going to be positive. And what happens if I go from here to here? What is my rate of change? Well, from here to here, I'm going down and then I'm going up. Did I go down and up the same amount? So really, did we change it all? No, so my rate of change there would be 0. So we have to ask ourselves, how are we going to calculate the rate of change when we're given a function like a parabola? And the answer is, we are going to use the rate of change formula. And that's our main focus for the rest of class today. So we can be asked to find the average rate of change from an equation, a graph, or a table. And in order to do that, we're going to find 2 points. And we're going to use the rate of change. So our 2 points are going to be x1, y1, and x2, y2. And what we're going to do with those is we're going to use the average rate of change formula, which is just a fancy way of saying we're going to use the slope formula for these 2 points. So remember, that is y2 minus y1 all over x2 minus x1. So I know a lot of you like to use delta y over delta x. That would be another way to look at it. So to find the average rate of change, you're going to write out your two ordered pairs and you're going to use the slope formula above. And depending on the 2 points that you get, your rate of change could be negative, it could be positive, or it could be 0. All right, so let's go ahead and let's practice that. So rate of change. Use the function f of x equals x squared plus 3x minus 5. Find the average rate of change from 0 to 2. So the first thing I'm going to do is I'm going to go to my y equals and I'm going to type it in. X squared plus 3x minus 5. Now I'm going to hit the graph just to make sure. This should be a parabola. Make sure I plugged it in right. Good, so we have it. So now what's happening between 0 and 2? So between 0 and 2 is from here to here. Well, what's happening between my two fingers? Well, it looks like, is it positive or negative? It's positive. We're going up, and we're going up pretty steeply. So let's go ahead now. Let's learn how to calculate that. So find the average rate of change from 0 to 2. So in order to calculate average rate of change, we need 2 points. So I need to change these into points. So this is going to become the point 0, comma, and I need to fill it in. So remember, not only does your graphing calculator do the graphs, but it also gives you a table. So I'm going to use my table to find the value of this point. So 0, oops, there it is, and the y value is negative 5. Okay, now I'm going to find my second point. My second point has an x value of 2, and I'm going to go down 2 and a y value of 5. Now that we have our 2 points, we can use our formula. So we're going to go delta y over delta x. So let's go ahead and plug it in. So 5 minus negative 5 all over 2 minus 0. Okay, so remember, negative, negative, keep change, change, plus a positive. So we're going to get 10 over 2, which then reduces to 5 over 1. So our slope is a 5. So our average rate of change is 5, and it's positive. Okay, so let's go ahead, let's practice this one more time. So next up, find the average rate of change from negative 4 to 1. So once again, we have to go ahead and convert these into points. So this is going to be the point negative 4, comma, and I'm going to use my graphing calculator. So negative 4, oops, and the y value is negative 1. And my x is going to be 1, comma, oops, and it also is a negative 1. So now we're going to plug it into our slope formula, our average rate of change formula. So negative 1 minus negative 1 all over 1 minus negative 4. So keep change, change, keep change, change. So we're going to end up with 0 over 5. But remember, 0 divided by anything is 0. So our rate of change is 0. Okay, let's go down to the bottom now. So I have this parabola is actually graphed here. So let's take a look. So between 0 and 2, we got a slope of 5 over 1. Let's take a look. So from 0 to 2, 0, all the way up to x equals 2 is all the way to here. Are we growing very quickly? Yes, we are. So does this match what we calculated above? Yes, positive and a positive 5. Okay, now let's take a look at the second one. So look at what's happening between x is negative 4. So I go over to negative 4, 1, 2, 3, 4, go down to where my graph is right here. And x equals 1. So I go over to 1, go where it hits the graph right here. So what's happening between those points? Well, it's going down and then it's going up. Did it go down and up the same amount? So did your rate of change stay exactly the same? Yeah. So that means the net change, the total change that we had was going to be 0. So yes, it has a 0 change. All right, so now let's go ahead and let's flip it over to the next page and let's try just a couple more practice problems. Okay, so number 2, a species of plant was introduced on the island of Koeppel-Keenan. To the right is a graph that represents the population of the plant over the number of years. What is the average rate of change from 10 to, and I am going to change this to 14 years. Okay, from 10 to 14 years. Explain what this means in context of the problem. Okay, so in order to calculate the average rate of change, okay, we need to find our 2 points. So our 2 points are going to be 10, comma, we need to figure that out, and then 14, comma, we have to figure that out. Now, since we don't have an equation, we're just going to look over at the graph. So here's my x is 10, I go over to 10, and my y value, I go up, and my y value here is 1,000. Now I'm going to go to 14 years. Over to 14, I'm going to go all the way up. And that looks like it's halfway between 16 and 17. So that means it's going to be 16,500. Okay, so now we can go ahead and we can do our rate of change. So y2, 16,500, minus y1, which is 1,000, all over x2, which is 14, minus 10. Okay, so then when I subtract that, I'm going to get 15,500 all over 14 minus 10 is 4. Now I'm going to take out my handy dandy calculator. Let's go ahead. 15,500 divided by 4, and we're going to get 3,875 over 1. So let's take a look. So from 10 to 14 years, 10 to 14 years. Okay, look at how steep that line is. All right, also, is our equation going up? Or I'm sorry, this would not be an equation, this would be your graph. Is your graph going up? Yep, so it's positive, okay, and it's a pretty steep, and that's a pretty big number to go with it. So we just found our average rate of change. Now explain what this means in context of the problem. Well, this means we're talking about a new species over the years. So this means species will grow 3,875 plants every year. That's going to be the average. And you've got it. Okay, last question for today. Let's go ahead and take a look. So now we're going to take average rate of change from a table of values. All right, so the table of values to the right represents the depth in feet of a scuba diver under the water every minute of his dive. So his minutes, he starts at 0. He's going underwater, 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 deeper and deeper and deeper. Oop, and then he starts coming back up, and at 13 minutes, he's back at 0, so he's back to the surface. So if I take a look at my y values, the scuba diver's going down, and then he's going back up. So this would be a parabola. Given the table, determine the average rate of change from 7 minutes to 11 minutes. Okay, so that means we need to find our points 7 and 11. All right, and this time it's pretty easy. We just have to look over here. So at 7, he's at negative 36, and at 11, he's at negative 20. So now we just have to use our average rate of change formula. So negative 36 minus negative 20 all over 11 minus, oops, sorry, I mixed that up. I did the 36 first. Sorry, we have to start with the y2. So negative 20 minus negative 36 all over, and then 11 minus 7. All right, so that means we got to keep, change, change. So we're going to end up with a positive 16 all over 11 minus 7 is 4. So our average rate of change is 4. So what's happening? If it's positive, does that mean he's going up or down? That means the scuba diver is going up, and he's going up. And what's the rate in context of this problem? So the diver is increasing depth on average 4 feet per minute. Okay, at this point, I am going to have us skip part B, okay, because we're running out of time, and I think you've figured out exactly rate of change. You're going to always be using your slope formula, and what I'd like you to do next is I'd like you to flip it over, and I'd like you to practice questions 1 and 2, and I will see you all in class tomorrow.